Welcome, everyone, to the Postman Enterprise e-commerce webinar series. We're at episode 2 here. We're going to be talking about deploying and monitoring your APIs using an API-first approach. My name is Ken Lane. I'm the Chief Evangelist here at Postman. My role is to help light the fire under your imagination about what's possible when it comes to Postman. So the purpose of this webinar is to help show you how Postman can be used as not just an HTTP client, but can also help you think about the larger API lifecycle at your organization. I joined Postman about 8 months ago, but I've been studying the technology, business, and politics of APIs for the last decade, and I'm just bringing what I know here to share as part of the Postman team. So let's take care of some housekeeping, get it out of the way. So this is going to be about roughly 60 minutes, about an hour, and then I'm going to do some Q&A, which will go for about 15 to 30 minutes, depending on how many questions we've got and the details of the questions. We will be publishing a recording of this. So if you jumped in late, you can grab the video, or you can just refresh yourself at a later date. So this is episode 2. I am gonna, the slide deck has some of the same elements of the talk we gave for episode 1, but the demo portions are completely original and unique, but you really don't have to attend the first webinar to know what's going on. And if you need a refresher to catch up, you can go grab the video. Because of the volume of people we have on, chat may be disabled, and there's no audio for anyone. I'm only going to be the only one talking here today, so I'm not going to be able to hear you. If you have any questions, I recommend you head over to Twitter. We're going to be tagging questions using the Get Postman handle, but make sure you add the Postman Webinar Q&A hashtag, because our team's going to be monitoring that, and they're going to be feeding the questions back to me and helping me actually answer some of your questions during the Q&A portion of this. I'll remind you about that a little bit moving on here. All right, so what is this 3-part webinar series all about? So the first one was about building and testing your API using an API-first strategy. And now we have a handful of APIs that we actually want to deploy. And then we want to monitor and execute our tests that we developed in our last series. So I will recap as part of the demo portion a little bit of that to kind of set the stage for how we built and test our APIs. But this one is going to be just about deploying and monitoring our APIs in a consistent and reliable way across teams. And then our part 3 of our series, which will be in May, is about going to market, actually bringing those APIs live. In this case, it's going to be making them publicly available, but that'll apply to if you're going to just bring it to market internally or with partners within the enterprise. So why are we here today? Every piece of software is used either is an API or uses an API. They're ubiquitous. They're behind everything that we're doing online and on our mobile devices. But really, it's been 3 shifts that got us here. It was the shift, the consumer shift from desktop to mobile, putting the internet in all of our pockets. It was the enterprise moving from building monolith applications to building more distributed microservice-driven applications. And then along the same time, really it's about moving to the cloud. It's about moving all of our data from on-premise and within our own data centers to run in any cloud. So it's mobile, microservices, and the cloud really kind of set the stage for why we're here talking with you today. From our vantage point, over the last 5 years, it's been some pretty phenomenal growth. When we started tracking, there were just 500,000 or 1 million Postman collections out there. And then now in 2020, we're pushing 35 million Postman collections. This reflects not just the public APIs you see showcased as part of programmable web and other publications. This reflects internal APIs. This reflects what enterprises are doing with their APIs within their firewall. So some pretty significant growth in the number of collections and how APIs are being put to work. You can see this across a lot of different business verticals. This is just a sampling of the companies and the industries where APIs are touching. But you can head over to our API network if you want to get a more sampling of this and actually start kicking the tires on some of these APIs. During the course of this evolution over the last 10 years, we've seen API first businesses emerge. I think one of the most well known is Amazon and introducing the cloud into our world. But really, companies like Twilio and Stripe are the gold standard when it comes to thinking about API first and how you build not just APIs, but you build a business with APIs at the center. All of this has really showed the average business and enterprise institution, government agency, that you have to be thinking about APIs first. You can't be doing API last development where you build all your web, mobile, and other applications first, and then your APIs are an afterthought, something you build along the way or after the fact once you've already published your applications. So companies are really learning from Amazon, Twilio, Stripe, and others when it comes to thinking about how you build applications that are more API centric, and APIs are the first part of that conversation that you have. And that's what we're going to highlight today. So to help frame this conversation and make it more valuable and just give it more context, we've created a virtual e-commerce company called Union Fashion, where eventually we're actually going to be selling some products and trying to run it like a real business. But it helps us think through this in the context of a real world business. And so this webinar is all about building out the APIs that Union Fashion needs to do business. And to set the stage for our story, I'm going to be assuming the kind of persona of Jeff Jones, the VP of Engineering for Union Fashion. And I'm going to be thinking this through in terms of what Jeff's looking to accomplish. And he's got his sights set on Black Friday. He really wants this to be a different way of doing business this time around when Black Friday comes around. So he's really looking to think differently when it comes to his team. And right now, it's really hard for his team to collaborate and work together. And so Jeff is trying to come up with some new processes and practices, coordinating with the teams that help deliver what each team needs, but moves APIs forward in a consistent way. And so Jeff's going to be working with his Q&A team, Susan, the front end team who's led by Alex, and he's also got a back end team lead named Kim. And so you're going to hear me referencing these folks, trying to bring some more context to how these APIs are being rolled out and how they're occurring. So let's leave the slide deck here and let's actually start doing a little demo and seeing how all this works. So for the walkthrough here and the demo portions, I'm going to have Postman client open on the left side, and I'm going to have my browser open on the right, kind of walking through the different areas of how we built this out. So for our last session, which was all about build and test using an API first strategy, we focus on the kind of organization of all of it. We set up a GitHub organization that helps us manage all of the APIs we're going to be developing. And we've set up individual repos that help us organize each of those individual APIs that we're building, as well as general operational and a homepage to kind of find it all and bring it all together so people know where to go when they're looking to get up to speed. Within Postman, we've managed our team and we've set up workspaces, much like repos. We've set up individual workspaces for each team to be able to develop APIs. So there's a one-to-one relationship here between these Postman workspaces and the GitHub repos that we're using to make things work. All of the APIs that we're developing as part of the Union Fashion e-commerce enterprise implementation utilize OpenAPI 3.0 as the central contract or truth of each API. So each workspace We're managing APIs here. There may be one or many APIs, but we're trying to keep them pretty small and organized. We have our API contract here, and we've generated collections to help us deliver across different stops of the API lifecycle. We've also set up environments that help us manage the different environments and stages of the development of each APIs, helping us abstract away keys, secrets, and other things that we're going to need throughout the API lifecycle. Using the collections that we've generated, we're generating mock servers. So we've published a documentation collection here that we've also published mock servers that allow us to actually see what's happening and make calls to the API. We've also published documentation from this collection, allowing us to keep our docs and mocks in sync. We've also ensured that there's a contract testing collection for each API that provides basic level of tests, allowing us to run against each API and do basic contract testing, making sure that each API is following the intended design and pattern that's set out as part of its open API. We've also deployed a performance testing collection that allow us to monitor the performance of each API and evaluate it from different regions. And then the team's begun work on some security, now that we're deploying some security collections that can help us evaluate the security of our APIs that we're developing. So all of this, the organization of it, the usage of open API, environments, collections, and then having our docs, mocks, tests, all self-contained within a workspace, allows us to isolate the feedback loop around each of these APIs. So we're using the comments for each API to leave notes for different people on the development team, allowing them to collaborate and leave notes directly on the API definition itself. We're also using comments within the collections. So if we have specific comments about a specific path as part of the contract testing, we can click on and see comments and see the feedback that's going around each individual collection request, as well as the core API itself. Now we're also, since every individual API has its own repo, we're using GitHub issues as the central place where you leave any feedback around any individual API, providing a feedback loop that's got a wider reach than just the team that has access to each API's workspace. General feedback being around the home repo within the GitHub issues here, if it's generally operational related. And you can find everything here about Union Fashion here on the home repo README, including the organizational structure and all the APIs and planning process. You can find the outline for this actual episode here, and you can participate in the go-to-market episode planned for May if you so choose. So with all of that, we have a handful of APIs here. So we're going to focus on our products API, which is this kind of center of our universe right now. But we also have orders, baskets, search users. We have other APIs that we're rolling out to help us meet our need, but we're going to focus on products today. So our products open API is pretty much ready for version 1. We are semantically versioning all of our APIs. So we'll be using a major, minor, and patch approach to versioning our APIs. Each open API will reflect the version here in the open API contract, as well as here as part of the Postman versioning. So we'll be managing the version there in both the contract in Postman, as well as here, we're syncing every open API from the workspace to its GitHub repo with the version in the name. So if I go back here to my GitHub repo for the products API, I'm going to actually see that open API right here with the version in the name. So I can actually work with each version of the API in the repo or in the workspace, and they're actually synced between the two allowing us to keep our API contracts in sync. We will be managing each individual contract or collection that's generated from this contract. Using the changelog, we will be applying version tags to specific points in time of the changes of each of these collections, defining how it's moving from every major as well as to minor or patch version of the API, helping reflect our roadmap and our changelog in each individual collection, as well as the overall open API definition and on GitHub. So all of this allows us to manage change and have a strategy for how we're going to be dealing with change across the organization and across the different APIs, keeping Postman and GitHub in sync when it comes to this change management. But now we've actually got these open API definitions. We've got a product's open API definition here. It's pretty basic to be for a version 1, but that's fine. We really don't want to gather other requirements and features and build things in here until, so increase the font size. Sorry, I'm going to pause a little bit. All right. I did increase, but we're going to zoom in some more. And I know for the GitHub, when I zoom in on it, I'm going to, my toolbar changes here, but we'll zoom in a bit. All right. Hopefully that helps a little bit. I know, whoops, no, I don't want to go that far. That's why I don't want to lose my left-hand nav here because it's pretty key. Hopefully that helps. I do want to keep this two-pane format. I know it makes it a little bit harder to see, but understanding the relationship between Postman and GitHub, as well as the client and the dashboard for Postman, I think is an important part of this. So I'm going to try to keep that a part of the conversation or a part of the presentation here. So we have our API contracts. We actually need to deploy this. I mean, we've been able to move quite a ways because we've mocked and documented and kind of iterated upon the design of these APIs in an API first way here in Postman. So teams have already given a lot of their feedback on V1, and they're just really chomping at the bit to get their hands on it. Alex, the front end engineer, really wants to just start playing with it in an app before he gives all of his feedback. Susan, the Q&A lead's pretty happy. She's got her contract test, performance, and other testing kind of groundwork laid. So she knows that her needs are going to be met. So we're in pretty good shape. So let's go ahead and deploy this API. So Jeff really wants to help teams be more organized and consistent in how they deliver APIs. So Jeff's really interested in creating a repeatable approach to how APIs can be delivered, and using Postman is a great way of doing this. So what Jeff's done is he's worked with his backend team to actually develop a handful of collections that he's put into an operations workspace. So if we switch here to our operations workspace, we can find a handful of collections that we're going to be using. These are actually deployment collections that we're going to use to deploy our products API. You can find these under Union Fashion. If you go to the GitHub org, click on the operations, you can actually see these collections here, and you can actually kick the tires on them. Be kind and gentle. They're always a work in progress. And if you have any questions, you're welcome to leave them here using the GitHub issues for the operations repo. So I've got two deployment patterns that I want teams to really be thinking about and using. So I'm going to share these from my operations workspace, and I'm going to actually share them to the products workspace so that they can be applied there. I'm going to share both of these. All right, so now I should have two new collections available in my products workspace. And if I go back here, I've got my basic contract, documentation, performance, and security collections, as well as the working one that I use for just creating new requests. But I have two down here And I have one that's um, deployment for AWS API using the API gateway as well as DynamoDB. So this is the first pattern that is pretty simple. It just uses API gateway and DynamoDB to deploy the API. And this is the most simplest form. It won't allow you to deploy APIs that have a robust schema or too complicated. But for very simple APIs, it works very well. And there's no code. There's no middleman to go wrong. So you can just map a NoSQL DynamoDB directly to the API gateway. So I have a collection here. What this is going to be doing is I'm going to select and change my environment because I have an environment that manages the state of this API being deployed. And I have a specific one for deploying product using this DynamoDB pattern. And what this is going to do is this first request here is it's just going to pull my open API from the API builder. So if I this open API for this specific version, I'm going to pull it. I'm going to run this request. And what this is doing is just loading it into the database, into the environment here. So the open API that I'm using to edit this is now in this environment. So I can use it for multiple steps here without calling the Postman API each time that I need it. So it just helps me be a little bit quicker and more efficient with the API calls that I'm making to Postman. My second call that I'm going to make here is actually to the DynamoDB instance that I'm using, and I'm actually going to create a table. And this is actually creating a table called products, which is pulled from the OpenAPI schema, grabbing that name and creating the NoSQL table that I'm going to use for the backend of my API. Next, we're going to prepare the OpenAPI for publishing to the API gateway. OpenAPI provides the meat of what's going to be deployed, and we need to add some vendor extensions that are AWS API gateway specific, helping us map each API endpoint from the API to the backend DynamoDB. So we're just going to generate that. And all this does is it just auto updates the environment the open API in the environment, adds those vendor extensions, and we're ready to go. The fourth step is we can actually publish this to the gateway. So it's going to grab that open API that we just prepared, and it's actually going to publish it to the open API gateway. So I've now got an active instance of the API gateway with all kinds of actions that I can take against it. So this is my basic products, DynamoDB API. Should be able to come over here to my AWS API. And yep, there it is. So I've now got a products DynamoDB API that I can see over there. But that's just an API. I haven't actually deployed the API. In the context of AWS API Gateway, you have stages that you can deploy to. So you can name your stages whatever you want. Most common being like development, staging, production. But you can call them anything you want, and you can deploy any of these APIs that you publish to any stage you desire. So we're going to go ahead and deploy it to a development stage because we're not quite ready for production. But now we've got an actual API that's available. But part of our open API definition was that every single HTTP method has to require an API key. We don't have any publicly available APIs, and everyone's going to need an API. So once we deployed that, you can't actually access it publicly or directly without a key. So before we can use our key, we have to create a usage plan for this API. So we're going to go ahead and create a usage plan. And what this does is it basically just creates a wrapper for a usage plan specifically for this API. That is called products, and it limits the quota of what people can ask for in a single day. When we rate limit and throttle by the second, allowing people, requiring that people can only access so much. We can change this after the fact, we can evolve it, and we can tailor it for specific customers. But all APIs should have a baseline limitation in case that API ever gets in the hands of of an unsavory actor, the damage that they can do is now limited. Now we actually need an API key. So let's actually generate an API key using the AWS API Gateway. So now we've got our key here. And then we're going to associate it with the plan that we just created, because you can put keys into multiple plans, giving one key access to multiple APIs. So we'll deal with that later in the go-to-market, and how we're going to apply service composition across the different plans and APIs that we're developing. But for today, we just wanted one API up with a key and a usage plan so we can get at it. So the next call is actually make an API call, and live demo code gods forgiving, I should be able to hit this and it gives me an API response. I get an empty array. That's positive. That's good. I get a 200 with an empty array. Haven't added anything into my API, so that makes a lot of sense. So the next one is I've got a post call with a body with a really simple ID, name, and description of my product. And you can see I've been testing the hell out of this. So I'm going to go back to product one. And I'm going to hit send. And I get a 201, which I like, but I get an empty object, which we're going to have to change. See if anybody's commented on this one, actually. Yeah, this is, I'll talk with the team and we'll add an issue and talk about how this should be returning. Should it return the ID? Should it return the full body? We got some work to do here before we actually publish this. But we should be able to then actually make a call and see our API, see our product that we added. So we've got an actual NoSQL API that's been deployed to Amazon using Postman, using an open API contract that we're managing using API Builder. So that gives us one pattern that teams can consider when it comes to actually deploying APIs for any purpose. Now this is, as I said, this is just for simpler APIs. We're going to use it for logging, keywords, all kinds of really basic things that won't have complex structures. But then immediately, when I was talking to Kim, our back-end engineer, she's like, well, we've got some more complex, robust APIs. That's going to get us about 10-15% of the way. So we need actual code behind APIs. And we'd really like it if we leverage new serverless approaches to do what we got to do. So we got to work building another pattern. We got to work building a more robust one that uses the AWS API Gateway, but it uses Lambda and RDS Aurora as the backend, giving us some serverless code in between each individual HTTP method that we can eventually evolve and customize and expand to meet the needs of each individual API. Right now, we're just going to deploy basic CRUD functions, but we're going to walk through what's involved with that. Serverless is slick, but serverless takes some time to set up. It takes some real considerations when it comes to deploying APIs like this. But it's something we can do entirely using the AWS set of APIs. So we're going to be using the Lambda API, RDS API, as well as the AWS API Gateway. We can map out every step along the way, helping us understand every single detail that goes into how an API is deployed as part of the Union Fashion team. So Jeff's really keen on this being mapped out. I'm not going to run each step like I did for the DynamoDB, because what I'm going to do after I'm done here is I'm going to just run this using a runner and deploying this API as a single step. But I'm going to kind of breeze through these main areas, which you can find here. If you go to Union Fashion org, you can find under Home. And if you go down to the planning section, you can find the deploy and monitor planning here. Here's the outline for what we're looking at here. So like the DynamoDB, we're using our open API as a central truth. We're going to pull that into the environment. But to create our table in RDS, it's not, you can't create tables directly in the RDS API. You need SQL to do it. So I've spun up a temporary Lambda function that we can then run, and it'll create our table, our products table for us. And then there's a call to remove that Lambda function because we don't need it anymore. Our table's been created. And then we have to do with Lambda, you need all of your Node.js dependencies to be able to run each function. And so because our Lambda functions are Node.js and work with MySQL, we have a handful of dependencies that each Lambda script's going to need. And in Lambda land, you can manage that using layers, Lambda layers. So we've got a base layer package that will deploy. And then for each individual path or HTTP method in our open API, it's going to generate an index and a package.json. And then I'm going to package that up as an individual Lambda package. And then we're going to deploy those as individual Lambdas using AWS Lambda over here. And then we're going to actually deploy our API similar that we did with the DynamoDB. But this time, each API path is backed by a Lambda script rather than directly connecting to the database. And this is going to allow us to pull data from the database, but then eventually inject other code and other things within that we're gonna need. And so I won't walk through each individual step here. What I'm gonna do is I'm gonna actually run this as a runner. So you can click in the top corner and you can create a runner. As you can see, I've been testing the heck out of this to make sure it works and make sure it all does what it needs to do. I'm going to choose my collection here, which gives me all of my steps here on the right hand side. I'll expand a little bit. And then rather than using my DynamoDB environment, I'm using my Lambda RDS environment. And I'm going to run this, and this is going to run every step. But you'll notice one thing, there's a handful of these steps that need to be run for each individual HTTP method. That's why it's better to run this as a runner, because you can build in the logic that'll loop through building of 5 index.js's, 5 package.jsons, zipping up 5 Lambda packages. And for each API method that you add, that's just going to exponentially grow. So having this as a single deployment helps out a lot. So I'm going to run this, and then fingers crossed, we get a clean run. And it's just going to step through each of my functions here, building out what's needed. Looking good. It's actually zipping them up, packaging them up to S3 for deployment. Still going, but we're getting green, so I'm happy. All right, deploying to the stage, adding my key, and then our last 2 calls are gonna fail because these are Lambda functions. The API was still being provisioned, and that cold start with Lambda gets us. So we'll have to augment these scripts with some retries and to just kind of keep looking until it works. Otherwise, it's always going to show that those last 2 steps failed. So let's actually go back to our Postman here, go to our individual test request here, and fingers crossed we should get an, oh, look, I'm still on my DynamoDB environment. Let's go to our Lambda RDS environment. And we've got an empty array. Got a little worried there because I had a product in there. I was like, wait, what's going on? But just like our Lambda one, we've got an empty array. We've got an empty API. I've got an add request here with a test product. I'm going to hit send. And see, look, I've already got inconsistencies between each of my APIs here. I get an identifier back with this one where I didn't with the other one. So our teams are going to have to actually check for that when it comes to tests, because this was a test escape. We were checking for valid JSON and a valid 201 response, but we didn't actually say what that payload should contain. And so that was a test escape that I know Susan's going to want to catch our Q&A lead and build into this. So now we've got a second API. We've got one that's a little more robust. It's got Lambda functions. Let's go over here to our API gateway. Let's refresh. Yep, we've got a products API that's Lambda RDS. Let's go to our Lambdas here. Yeah, we've got some Lambdas created, and these are all mapped to our individual API paths. So teams can evolve these independently. We can evolve the generation script that generates them and redeploy these to add in more custom functionality. We've got a lot of plans for what will happen next. But now we have two actual APIs. For products, we're probably going to go with the Lambda version. We won't keep the DynamoDB, but for the sake of this demo, I wanted to walk you through them both. So we're going to go ahead and keep the Lambda edition of this, but we want to make sure that this API is actually reliable. I showed you how we had some test escapes. Susan's definitely concerned with this from a Q&A perspective, but Alex front end, really wants to be able to start building apps on this and make sure that these are reliable APIs. So even with a development deployment, any stage deployment of an API, whether it's development, staging, or production, we should have a set of monitors that help us actually keep in tune with us. But before we move on to that, I wanted to showcase the management layer of this. If you notice, each of these have a usage plan, API key, and steps. Every API should have this management layer. Everyone should require a key. I don't care if this API is being used internally for administrative purposes around this API by the core team. It should have a key that can be refreshed, can be managed, and be limited. Every API should be rate limited and have a basic plan set up. There's no API that should go out the door for any purposes that does not have a management layer. All APIs should also have environments. So for each stage, we've actually deployed an environment, and this is where we can actually put our URL and our API key that AWS generates. We can, we'll also be maintaining environments for mock environments, so that when we actually are working with any of these APIs, there's a mock instance, so we don't have to burden the AWS infrastructure, deployment infrastructure. Q&A team, Susan's Q&A team, or Alex's front end team don't have to worry about working with live data. There's always a mock instance available as well. So there's environments to track each stage, but there's also environments to track the life cycle. As you can see, I've got an environment that maps the entire deployment using DynamoDB or Lambda. So I've got a footprint, I've got timestamps of each step for the API deployment process. And that really helps us later on for governing the entire API lifecycle, which will be future editions. So we have these APIs with collections, we have the APIs deployed, we have them with environments. Now we want to actually make sure that they're going to meet their contracts and do what they need to do. So for our contract testing, we're going to deploy a monitor. You can deploy new monitors using an existing collection. So we're going to choose our contract test for products. So we're naming this products contract testing, keeping with the common naming convention. We're going to be using our versioning strategy, and then we're going to be using the environment that we want to be testing against. So we're going to be testing this contract against our dev environment, and then we can choose what frequency we want to run this contract test for our dev environment on. Probably hourly is a little too much. We can go every 12 hours. During development, that'll probably make Alex, the front end team, feel a lot better, as well as Kim on the back end team. So we're just going to do 12-hour monitors for development, and then we can manually select which geographic regions. For development, we're too concerned with this. We're going to just let it automatically select. But for production, we're going to actually want to monitor the API based upon where our customers are at, making sure that the contract is being tested from that region. So we can create this monitor, and we're going to run it for our development environment. And we're also going to set up monitors for performance. So we can set up a monitor here to monitor performance versioning. We're going to use the product environment and performance. We probably going to do an hourly timer every hour. And again, it's development, so we're not concerned with each region. But once we do deploy into a production environment, we're going to choose the regions based upon where our customers are at. So we're able to run contract tests and performance tests for the API that we just deployed, ensuring that it's meeting its basic contract level requirements. It'll be running the tests against the responses. So you'll see the test results here. All the test results for the contract testing and the performance get stored in the environment. So when they're run, the results of those tests are actually here in the environment. We ran it against the mock, but the same applies to the dev environment. So basically, all the results of our performances are available in the environment, giving us that picture that we need about what each API is doing or not doing. And then we can choose to publish those environments anywhere else and generate reports and other things from them. So that gives us an overview of what's happening at any point and whether we're meeting our service level agreements and doing what we should be doing. Along the way, you saw that I actually have a mock API here. Every stage should also have a mock representation of that contract. That mock can be used for testing, and as I said, it can really be used to help alleviate concerns around PII, access to production data, or even access to development data that a certain tester or developer is using to kind of accomplish a goal. So if people want to play around and kick the tires on it, every stage should have a mock representation. And using Postman, that's really easy to do alongside each API that we're deploying. In addition to being able to have an up-to-date mock, once we've deployed our API, we should always be publishing docs. So there should always be a representation of the API available for browsing. So we should be able to share this URL with internal teams. They can find it as part of the team workspace. We have them published as off of the GitHub repo. You can find links to the documentation. You can see examples. You can see how well or how not so well some of the paths are documented, explaining how to use the product's API. And then, of course, there's the environments and the run in Postman button here for teams to actually start playing with, putting it to use, and evolving each individual API and providing feedback. So they're able to actually work and iterate upon these designs, and the documentation helps make things much more tangible. So documentation is always essential for Jeff to be able to collaborate with his team and make sure Alex and Susan, Q&A and front end understand what's happening, but the back end team can keep people, up to speed. And then once again, the feedback loop around these, the comments for each individual open API allows Jeff and team to be able to comment on the core truth, but then each individual collection That's one of the reasons why we have separate collections that can be run separately, can be monitored separately, but they can also be individual tracks as part of the feedback loop. So we can actually click on an individual endpoint and comment right here rather than commenting on Slack and referencing. It just makes it easier to be able to reference an API and what's happening when you actually comment inline. So inline comments in conjunction with having a structured approach to how collections are generated, derived from the Open API truth, and then used to deliver different stops along the API lifecycle. This is for docs and mocks. This is purely for contract testing. This is purely for performance. This is security. So now we have individual collections who can deliver on those stops along the API lifecycle, but then also we've got individual feedback loops with the comments for each of those so that we can actually have threaded conversations around specific stops along the API lifecycle. And then again, we're using GitHub issues. So GitHub issues provide us with the ability to actually comment wider with other divisions or groups who may not have access to this workspace. If this is a public API like Union Fashion is here, any of you can come here and submit issues that you're seeing with any of the APIs we're developing. You can submit feature requests for the roadmap, suggestions for enhancements, and we'll start organizing and managing them here. And this is actually how we'll be managing our change log and our roadmap for the future. So as part of our next go-to-market strategy, we'll be using that. So all of that really gives us the feedback loop we're looking around to have around these APIs that we've deployed and we're monitoring as part of our e-commerce enterprise API lifecycle. So with that, that concludes our demo. Now all of this helps Jeff, be more coherent and focused in how he works with his teams. Able to put ideas on this conveyor belt for many different APIs, and the team is just a lot more organized and structured in how these ideas move from design development into actually to be an actual production API. And so, in the previous episode, I went through each kind of layer of the Postman platform, showing how the platform helped us just deliver what we did. I recommend you go back and watch that video, and you'll get a view of it. This round, really think about this as your Swiss Army knife when it comes to implementing what I just showed you. The point here really being is most people know Postman as a desktop client. This left hand, single area here. But really, when it comes to CLI and what's possible with Newman, and everything I just showed you is Postman API driven. This is how you're going to get things done. This is how you're going to develop integrations. So Postman is a platform showing you the relationship between the desktop, the CLI, and the API, and the web. We're starting the migration to what we call Project Artemis and moving things to the web. That's why I had the dual screen Postman client and web open. So I really encourage you to start thinking about Postman as not just an HTTP client. It's much, much more. But really how you use those core runtime features are critical. I mean, collections, it's not just Postman. It's an open source definition that you can use to organize every stop along the API lifecycle. You can define all the APIs you use, as well as every stop along the API lifecycle as I showed. So your runtime is really the base for what you're going to be developing. And then all of the orchestration that I showed you as far as building your team, setting up your org structure, getting the workspaces in alignment, having a coherent strategy as Jeff's done for his team here is important. That's how you're going to be able to set the table for your teams to properly collaborate and do what they need to do. And then with all these definitions and your teams in alignment, you can really orchestrate a lot of magic when it comes to documenting, mocking, monitoring, and really understand what's going on. And as I showed you, you can define this stuff as collections, and you can orchestrate with those collections, actually deploying APIs in an automated way. And you have all the enterprise level stuff going on behind the scenes. We have role based access control. We have SSO already set up. So really enterprise grade features and usage that our enterprise organizations are used to. So between episode 1 and episode 2, this picture should really be coming more into focus. How do you move from API last to API first? Well, episode 1 talked about how we define, design, document, mock, and test APIs without actually building any applications. Sure, Jeff, as part of the process, is reaching out to Alex, the front-end application developer, as part of the process, but we're not building those apps yet. Now we're deploying APIs, and Jeff or Alex, the front-end guy, can start building on those and mocking some apps and building on the APIs we've deployed, and then providing more real feedback. And then we can choose to iterate on on the design a little bit more before we move along. It's up to Jeff to work with his team how fast they move on all of that. So this all helps Jeff move and realize towards moving from this API last mentality that they're in, and start shifting kind of team perspective and how they deliver things to an API first approach. Jeff and teams on the enterprise license, because they wanted custom pricing, but the SSO, the RBAC, and all of that, and just the general team size that he's looking to grow this to was ideal. So right now it's a core team of 50 or less, but Jeff anticipates moving over 100 users pretty quickly. But all the features that I showed you are available in the free team and business environments. It just really comes down to the scope and the visibility that you're going to want into how things are occurring. Enterprise is just going to give you more audit reporting and visibility and observability into what's going on. So Jeff's made sure that everything's set up for that. But this is all an API first journey. I recommend you jump on Postman community when it comes to any of your questions. The Postman team's on there regularly answering questions. The community can chime in and help on a lot of things. I also recommend you look at the API network. API network is where you can, when you're publishing docs, you can publish your API publicly and make it available. We got quite a few providers there that you can learn from. Most of the APIs that I'm using, there's some representation of them there. And then everything's on GitHub. Postman operates pretty heavily on GitHub, so you can see our application support on GitHub. If you have any questions, you got features you want to see in the roadmap, it's definitely visit the GitHub repo before you tweet at us or hit the community channels. Also, Union Fashion is all on GitHub. All of this is set up as a public GitHub org with public GitHub repos. Every API, every planning session, every detail that went into this webinar is being done live there. All the collections are available. So if you have any questions, if there's anything you would like to see, I would like to invite you to be part of the conversation there. We're going to keep doing that. It helps us be transparent and more observable in what we're trying to accomplish. And with that said, that's the conclusion of this Deploy and Monitor webinar, but we've got some time for Q&A. I'm going to spend about 15, 20 to 30 minutes here answering questions. Looks like the question load was a little lighter, but you can hit Twitter and hit us with some questions. But if you fill out this survey, it's a bit.ly Postman survey, you will be entered into a chance at winning a $50 Amazon gift card if you complete it during the Q&A session in the next 30 minutes. So I recommend you. I'm going to leave this up on the screen, and then I'm going to see if I can't answer some questions, but I'm gonna have to go out of full screen mode because Zoom and Keynote don't seem to jive. So where should I go here? Should I look in? Looks like I've got some in Q&A. I'm gonna start there. um, Let me look at a few of these, see which ones are good. Does Postman support all major cloud providers, Azure, GCP, IBM? If it's got an API, we support it. As part of the union fashion right now, these are very AWS focused, but the purpose of these collections is not to say, hey, here is step by step how you should be deploying your APIs. It's more about here's one possible pattern that Jeff from Union Fashion chose. Here's how Jeff did it. You can build your own API collections that do the same. The concept, or you could take the collection and deploy it yourself. But it's more about teaching people the concept that Postman collections can be used for API deployment, management, and other stops along the life cycle, in addition to just making API calls. But your cloud providers have to have APIs, and luckily most of them do for almost every feature you're looking to do. One of the next steps I'm going to be doing in the next couple weeks is I'm going to replicate the basic 2 API deployment patterns for Azure, and then I'm going to look to try to do Google within a couple of months. So if you have a cloud provider that you're interested in, I will look forward to hear from you. Let's look at some of these other questions. What do you think about creating an AWS Lambda function that will post to Oracle and then create an API based on that? Totally for it. I think the model that I created for the Lambda and RDS, it's meant to be modular. You can swap out the RDS Aurora with an Oracle, change some of the SQL structure, and the Lambdas will do what you need them to do. So feel free to submit this your need for an Oracle database to the GitHub issues for Union Fashion, and we might consider putting it on the list of API collections to actually create. Rather than making calls to each of the individual AWS APIs to deploy the API, why not generate an AWS Cloud Formation? Because one, I work for Postman, and my job is to light the fire under the imagination for Postman. Two, Postman is an open source cloud platform agnostic format for mapping out each of those steps. And so it's really suitable for deploying APIs using multiple providers. I did not dive into my additional API lifecycle collection here, but one example is if I'm not using Amazon DNS provider, I'm using Cloudflare or others. How do I work with that? Sure, CloudFormation lets you work with other services too, but Amazon CloudFormation is going to always, all roads are going to lead to AWS services. And with Postman, it allows me to break down each step in a collection, so it's broken down by collection and folders. It's in an organized step-by-step way that even Jeff can step in. Jeff, the VP of engineering for Union Fashion, can't. He doesn't remember how to write code or make API calls. But with that collection set up step by step, he can see each step along the way. And then with the test environment that's in Postman, you can validate each individual test that it's working, and you can execute those as part of runners and monitors. So yeah, CloudFormation, Terraform, Ansible. There's quite a few languages for how you can orchestrate and map across infrastructure. But you can do that with Postman. And since we're already in, many developers, we have 10 million developers already in Postman, it makes sense to lay these out as AWS templates. All right. How much time? We got some more time. Let me look at my notes, make sure no one's telling me to do anything. Well, I'm just going to keep looking down the questions here. Does Postman support non-HTTP protocols like IoT and file-based, including automated tests for non-HTTP? Not currently. So we're within the realm of HTTP. So that's RESTful web APIs, SOAP and GraphQL. They're not protocols, but they're formats that fall within that. But we are looking at what would a Postman client look like for WebSockets? What would it look like for MQTT? What would it look like for HTTP2 and HTTP3? So we're experimenting with this, trying to understand. It takes a lot of work and a lot of consideration. So I recommend heading over to GitHub, Postman, or the Postman GitHub repo for app support, and plug in and look for any. I think there's some WebSockets and server sent events in existing conversation. Wade in on what you would like to see, because we're paying attention to that as we evaluate how to make Postman a multi-protocol HTTP client and platform. So if this is covered in the first session, let me know otherwise. Otherwise, I'm wondering about the feedback loop. How would you guarantee consistency between the API spec and the actual functionality, especially if you're using a no-code approach? So that will be covered in future sessions. The second part of his question here is, how do you validate design first spec with written code? Stated differently, how do you close the loop and make sure the spec and code aren't diverging? So the first part of that is how do you validate the spec? So you saw hints of it in my workspace, but I have a governance collection that will pull the open API and then look for certain patterns to be in place that's needed to properly deploy it, to properly document, mock, and test that individual API. So the test collections you saw there were for testing the outputs of the API. The additional collection I have is testing the surface area of the API to see if anything's changed. And for this purpose, because we're generating all the code, the lambdas needed from the spec, the process keeps things in sync. There's no keeping the code, changing the code because of the spec code. We redeploy to another stage, and then that's the next iteration. So the API contract within API Builder is the truth. And the reason why that I'm using Postman in this way and showing this is to help alleviate that pain. There's a lot of companies that may be API first, but they're still code first, which is fine. Writing code and then deploying an open API from your code is a very valid way of deploying an API. And you're still API first in theory, if you're doing it before developing actual applications. But that's why I'm creating these deployment collections, is to help alleviate that pain, and generating as much of the code. Sure, I'm going to hit a wall here where I still have to create custom code for some APIs, and we'll deal with that problem in the future. But to approach your second question, how do you make it so your code and your definitions aren't out of alignment? One, you try to be definition first, and you generate as much code as you possibly can, or bits and bytes of that code. Second, you have API tests that actually test for as much surface area of that API, test for actual results, actual values in there, and look for changes in the API behavior that's driven by code changes. And so the robustness and scope of your API tests are going to help you do this. Beyond code generation and robust testing, if you're still code first, you're going to have this problem, and you're just going to have to think about it. Any features? How do we test this in the surface area of our API? It's an ongoing challenge. There's definitely no silver bullet to it. Excuse me. All right, we got a few more minutes to go here. I'll keep diving in Q&A. Looks like, actually, let me look. Did you guys give me any from Twitter? I don't want to neglect people who answered from Twitter. Question for Ken to answer at the end. Oh, that was the question I just answered. All right, well, cool. I will just keep working from the Q&A list here unless you guys scream at me in Slack. How do you keep deploy API Lambda in sync? I mean, when you make changes after running all steps, or even what I want to change generated Lambda code, how do I keep it all in sync? I don't have the answers for you right now. We're still working through all of that. Some of these APIs, the code's not going to change, and so the build process is what is the voice of the API. In an API first process, we should be able to add any iterations without writing code. We should be able to add paths, add behavior, see that working as part of a mock, see it be more tangible with the docs, get feedback on it, and then deploy it. There's not any changes that have to occur. But the next pattern that we're going to deploy is, what does the lambdas look like when we inject some code in there? How are we going to inject code in there? How are we going to test the code quality? How are we going to manage the versions of each Lambda in relationship to each version of the API? So there'll be versioning and management of those Lambdas. Excuse me. But that's part of the reason why I wrote the little Lambdas that package up the Lambdas and auto-generate, put them on S3, is we can automate a lot of that versioning and how that works. And so I'm going to lean towards definition first, generated second, custom code third. Excuse me. And then think about that, how we deal with that custom code as part of each layer. Is it code that can be managed as part of my Lambda layers? Are these just purely dependencies? Can I update my code generation to include code with these dependencies? So can I start developing another set of common patterns that can be used and be part of the build and generation process, rather than just leaning all the time towards custom code? But there will be places that have custom code, and we can build stuff in there that if the Lambda has been cracked open and changed, there's a flag on the Open API. It's detected it as part of the log files, and that Lambda won't be overwritten because it's been custom built. And we can start looking at, well, which teams are customizing Lambdas versus taking the time to go through a generation process, which might be a little bit lengthier and a little bit more time consuming. But the goal is try to standardize the patterns we're applying and shift behavior, not from code first to just no code or low code. It's code first. It's an API first with more thoughtful code being written as part of the process. There's a lot of pushback from teams on this because teams see themselves as programmers, not open API templators. But the coding's not going to go away. It's just going to be more precise. It's going to be more thoughtful, and it's going to be shared across teams. So this isn't a silver bullet, and we'll be addressing how we deal with custom code in the Lambdas in future iterations. Stay tuned. Let me look at my notes. All right. Let me hit some more Q&A. We've got some more time. Fantastic AWS integration. Any plans for Azure's URLs for documentations? Search for Union Fashion on GitHub. Everything's there regarding what's currently built, as well as the planning for Azure. Yes, Azure is next. And then I've got some people clamoring for some Google endpoints as well. So I'll be replicating and creating a whole suite of multi-cloud API deployment collections. Stay tuned for that. was this product API spec created by hand? No, it was actually created. I have another script that's in my API lifecycle collection. I guess I can jump over here real quick. I have what's called my full API lifecycle collection that has a lot of stops beyond just deployment and management. And I have this set of helpers that add individual APIs, paths, verbs, basically works from a components library. And so if I go back to my products API, this entire set was built dynamically using those scripts. I gave it a base schema that I wanted, and it auto generated a lot of this other parts and pieces working from a common components library. So I'm a big fan of not reuse, not handcrafting, but I really do like getting in here and actually touching and tweaking on things and having teams be open API literate. So finding a balance between auto-generated from components and then handcrafting is important. But the goal, similar to code, is try to minimize the custom things that happen working from common patterns that we're using. All right, got some more time for some more questions if my voice will allow here. Do I know how Facebook Gaming API works? No, sorry, I do not. Could Kin demo how the sync of GitHub and Postman is conducted so the API updates are maintained between both sites? I believe so. This is the second in a 3-part series. There's actually was one that planned this whole thing, and it was had the details of that sync. You can click on the sync for this, and it'll show you how to walk through. It's pretty self-explanatory. But you know what? I'm gonna write in my notes as part of Union Fashion to do just a video on the GitHub sync portion, because I think that's one that Jeff's gonna want for his backend teams to understand. So I'm gonna add a video for that, Mark, so you can tune in and check out the repo, and there'll be a separate little standalone video that walks you through the GitHub sync, because I think it's that important. How do you update each of the handful of collections from the Open API definition when there are new additions or changes? Yeah, this is something that's proving challenging, and I know our team's working on it from a roadmap vantage point. So the first part of this is try to generate your collections from your Open API. So use the generate collection button when you first get going, and then because that'll keep it in sync with this, and that gives you the ability to validate each collection. So when you're working on an individual request, each one can be validated. And when you're managing that API, it'll show you when there's issues found in each of the collections. And so this helps you keep a collection in sync with the Open API truth. Now, if you start making changes here and those issues arise, how do you get that back into your Open API? No way to do that right now. You got to do that manually. So those are things I want to work on to try to figure out how to use components to identify a new path was added here. How do we add that back into the Open API? And so that's a challenge. But if we're using collections to evolve an API, one thing I recommend looking at, and this is why I have this working one, is you can fork collections, and then you can merge those changes back in. So if Alex, the front-end API or front-end guy, wants to make recommendations on changes, he can fork this, start making changes, and then submit those changes back for Kim, the back-end lead, to actually merge into this collection. But then Kim's got to keep that in sync between the Open API right now manually. I'll write some scripts that are going to help Kim with that, But ultimately, that's still a challenge, and that's something we'll be working on as part of Postman is concerned. So the API builder is still fairly new. It only came out of beta earlier this year. And so we're looking for your feedback on best practices for how to do that. If you have your own organizational workflows and lifecycle and how you use open APIs and generate collections, I would love to learn from them so that we can have use cases to give to our development team to make that whole process easier. Thanks for your question, Darren. All right. How could we pull the structure you showed in Postman into our desktop client? So yeah, this is interesting. Is if you go to the Open API or the GitHub for this, everything is here. So you could, all of these collections are there. You could create a workspace called products. You could pull all these collections in here from the products API. You could go to the operations. You could pull all the collections in for deploying. I recommend you try, if you're going to try the deployments, try it with this open API, because there's a lot of assumptions that are made, things that have to be done in this open API for these to work. And so it's probably not going to work with a handcrafted or fresh open API. You've got to have your schemas defined. You've got to have your API keys. You've got to have certain aspects built. And I have a governance collection to address that, but it's not part of this yet. We haven't kind of fleshed it out. And so you could recreate all of this. I even have links if you go to any of the individual API repos. I even have links to the workspaces. So you can actually get to the web workspace for products, see all the collections. Problem is you have to have access to the Union Fashion team. And we don't have a way of just letting in customers and the public into that. So that's something that I would love to figure out, is how do we create a set of workspaces with collections, with APIs, everything that our customers can go in. I can make them read only and invite specific users, but I still got to work through that. So if you really are eager about getting in here, leave a submission on the GitHub repo, and it'll help me prioritize it, help me make this available so other people can come in here. And I'm going to keep developing APIs. So if you're interested in the overall Union Fashion workspace, if you're interested in a specific workspace, I'm going to try to make that as replicable and exploratory as possible. Thank you. I appreciate that question. So with that said, I'm gonna close it up there. I'm starting to lose my voice, to be honest. And we're approaching our time. So I know that we will be recording this, or we've recorded this. We'll be producing the video and publishing that, so you can get at that. I know our team's going to be going through the questions and making sure that more of the questions are answered. That's one of the reasons why we tried to do it on Twitter. Feel free to keep asking questions on Twitter. We'll keep monitoring it. I've been polling the tweets, and we're gonna process those. So we'll get your questions answered, and then make sure to head over to Union Fashion. It's pretty easy to find. GitHub.com Union Fashion. You can ask questions about the overall approach, individual collections. If there's features you would like to see, I've already got people suggesting new APIs that we could develop, new ways of doing it, the cloud implementation. Really would encourage you all to get involved and be part of that. So with that said, I think that's all I got for today, and I appreciate everyone coming and look forward to having you all in May when we take these APIs and go to market and actually publish them in a portal and make them available. So get involved, hit me with your questions, and we'll see you at the next episode. Thanks so much.